Welcome folks. In this video we're going to start our unit on linear relations, and we're going to start off by looking at some patterns and then using those patterns to build some equations. So that is our goal today. And just a reminder, in algebra class we're going to spend a lot of time talking about this thing called our algebra web, so I don't want to lose sight of this. So just remember, there's kind of four ways to represent the math. One way would be an equation, and we're used to that. If I give you an equation, you could plug x in and find y, or so on. And the whole point of this is that these are all connected. You could draw with a graph, or you could organize your data in a table and then create the graph, or so on, or maybe build an equation. But all three of these relate then to a situation. And of course this is the whole why would we do this, why do we use this math. So today we're really focusing on building this connection right here from a situation, in this case it's going to be a tile pattern, to create an equation. So let's jump into our first example here. So here is our first tile pattern, and so we have figure 1, which looks like this L, and then figure 2, which looks like an uneven U shape, and then 3, which is a taller uneven U shape. And so the first thing we want to ask is, well, what do we notice? What do we notice, or how does it grow? We notice about the growth, or the change between the pattern, between the tiles, we could say, or between the figures rather, about the growth. Well, the thing that I like to use a lot is different colors, because that really helps me see what's different between them. And the thing that I'm seeing, and you might see it differently, and that's totally okay, I see us adding, so from 1 to 2, this tile on the left side gets dropped down, and these two also go down. Because you notice here, what's left over, this part is actually exactly the same as this one right here. And then likewise, we actually see figure 2 inside figure 3, which it would be right here. And then once again, we see 1 dropping down on the left side, and then 2 dropping down on the right. That seems to always be the case, at least so far. Small sample size, sure, but it is a pattern. So I'll say that one tile is added on the left, and 2 are added on the right. I've heard in the past when doing this problem, some people like to think of these as like 2 towers being connected by like a little bridge or something on the right. Okay, so now the question is, let's think about this. What would figure 0 and figure 4 look like? 4 and 0. Well, we could draw them in here, so I'll add figure 4. I think that one makes sense if we just follow the pattern here. So we know, at least based so far on what we've seen, that we're going to add one more on the left. Let's maybe add these ones in yellow, I guess. We'll keep doing in green. Excuse me. One more right here, and then 2 more right there. So I think figure 4 is going to look something like this, and I'll try to draw it the same size roughly. Like so. 1, 2, 3, 4. Let's see, how many are in the bottom here? 1, 2, 3, 4. 1, 2, 3, 4. And then now I'm going to have 1, 2, 3, 4, 7, 8. So it might look something like this. Alrighty. So this should be one more added on the left, two more on the right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Perfect. And now if we're doing figure 0, well, this one's weird because we don't know what figure -1 was. Because if we know before -1, then we just add 1 to the left, add 2 to the right. But we don't have the one before 0. So we're going to have to, I think, go backwards here. And I could think, if I went from figure 0 to figure 1, the new tiles, again, well, the new tiles are the 1 on the right, 1 on the left, and 2 on the right. So I think to go backwards, oops, sorry about that. To go backwards, we're going to have to take away 1 on the left and 2 on the right, instead of adding them, because we're going backwards, so we're doing the opposite. And so if that's the case, then we're just left with those 4. Oops, that doesn't work out. Those 4 in the middle there. And so these 4, or it would actually be, that's what they became in the next figure. Alrighty, let's move on to our next question then. So this is all fine and good, but the question is, what now if we want to extend this pattern? What would figure 100 look like? Well, here's totally a way we could do this, and that would be to just follow this pattern all the way out. But that would, I think you could imagine that would take kind of a long time. And so let's see if we can maybe piece this together without doing that. Alrighty, so what I've done here is I've just cleaned up our existing tiles, because I think it's going to help us kind of get our thoughts organized. And so we notice that the tile pattern grows by the same amount. It adds 3 because, again, total 3 because it adds 1 on the left and 2 on the right. So going from one to the next is always plus 3. Plus 3, plus 3, at least to the total amount. The question is, well, what would figure 100 look like once again? And how many tiles would it have? Will it have? Well, let's think about this. One thing that I noticed is that each tile pattern kind of still has this little 4-piece bridge in between it. That doesn't seem to change because the figure isn't getting any wider. Okay, so that's always going to be 4 right here, 4 tiles. 4 tiles right there. Okay, so I do know that figure 100 is going to look like that as well. So it's going to have this kind of 4-piece bridge here. Maybe I'll try to draw a little bit better. 4 right there. Actually, I'm going to draw it in red just so we keep it consistent. And I'll highlight it yellow even. Okay. And here's really an interesting thing. Obviously, the left and the right little towers, they change. But we can kind of see an interesting thing here. I'll do some purple. The tower, which I'll highlight in green. No, we'll do blue actually. This one is only 1 tile tall. This one is 2 tiles tall. In figure 3, it's 3 tiles. And in figure 4, it's 4 tiles tall. And so we kind of notice, hey, that's only 1 tall, and that's figure number 1. This time it's 2 in figure 2, 3 in figure 3, 4 in figure 4. So I think if it follows the pattern, then I think this one in figure 100 is going to have a little tower. And obviously this is not to scale. I should point that out. This one is probably going to be 100 tiles tall. 100 right there. Hopefully that makes sense. And now we'll look at the pink tower on the right side. Highlight all those. Again, I really would encourage you to use colors when, if possible. I know not everyone has access, but if you do have them, I definitely encourage you using it. And if you don't have different colors, you could do different shading techniques, like, oops. You could do stuff like, one-way diagonal, and then you could do other diagonal, and you could do like cross hatching, if you will. Just other ways to keep your thoughts and notes organized. But I think if we look at this pink tower, let's see. This pink one, well, there's going to be 2 there in figure number 1, 4 here in figure 2, 1, 2, 3, 4, 5, 6 tall in 3, and I think this one is 8 tall. Well, it doesn't seem too obvious at first, but we notice, wait a minute, 2, that's 1, figure 1 times 2. 4 is figure 2 times 2. 6 is figure 3 times 2, and, well, 8 is figure 4 times 2. This figure 3 should be times 2. And so it seems that whatever the figure number is, times 2 tells you how many tiles are in that pink tower on the right. And so I'm going to draw that in here. This pink tower, if it's 100, it's going to be 100 times 2, which is 200. And so I think this is what figure 100 will look like. And then the total number of tiles, well, it'll be 100 plus 4 plus 200, so 304 tiles. Okay, last question here before we head out is, what would the equation be? And in this equation, we're going to use x to be the figure number. And it's always really important to figure out what the variables represent first. Y equals the number of tiles. Well, we can think about this, and I'm going to use kind of the same thought process that we use to figure out what it looks like. Well, it seems that every figure has 4 tiles in the middle to start. So I know that the number of tiles is going to start off with 4 at somewhere. That doesn't change. And so I'm going to use that in red as well. Y equals 4. Okay. Well, how did the left side tower come up? Well, we notice that the left side tower, the number of blue tiles, well, in figure 1 there was 1 blue tile. In figure 2 there was 2. In figure 3 there was 3. In figure 4 there was 4. In figure 100 there was 100. And so it seems like the number of blue tiles, let's write this out. The number of blue tiles equals the figure number. It's the exact same thing. The figure number, which in this case, we called it X, remember, just from up here. Blue being these ones. And so we're going to have to add those in as well. So let me actually write it out this way. Equals, let's see. I know what I'm doing, trust me. Kind of. So remember, the Y, the total number of tiles is equal to all the yellow ones plus all the blue ones plus all the pink ones. And we would add all those up. The yellow tiles, again, those are always the same in every figure number. It's always 4 of them. There are always 4 yellows. So that's why that's always there. We notice that the blue tiles that's the exact same thing as the figure number, which must be X. And the last part, the number of pink tiles, the number of pink tiles, well, that was always double. So that's the figure number times 2. And in this case, that would be the same as saying 2x or 2 times x. So now if we add them all up, yellow plus pink plus blue would be 4 plus x plus 2x. You might have heard the term collecting like terms, or the vocabulary collecting like terms. And the way we'd do that would be to say 4 plus 3x. Or, well, since addition doesn't matter to order, you could write it as 3x plus 4. And that is our equation. Alrighty. Sorry this video was kind of long, but we're going to take another approach to answering this question, how do we find the equation, in the next video.